Afternoon and Merry Christmas to all the participants. This is Prakshi and welcoming you all on behalf of FCP Index to this knowledgeable series program. In this one of the initiative by FCP Index to share the experience and knowledge of industries and experts with our associates who are working in the field of fluid convenience product. Before the start of this session, I would like to invite Mr. Anup Pillai, founder of FCP Index, to apprise about the vision and mission of FCP Index. Over to you, Anup, sir.
Thank you, Prakshi. Welcome, good afternoon, all the delegates. We welcome to this session, one of the most interesting session, I would say. Nidhesh sir, can you see the screen?
Yeah, it is visible, sir.
Okay. Yeah.
Only you need to speak a bit louder, please.
Yeah. Yes. Okay. See, welcome all delegates. Good afternoon. I'm Anup Pillai. Welcome to FCP Index. Welcome to this interactive session on cleanliness. Basically, I request everyone to mute your audio calls so that this can be a very smooth and interactive session for everyone. And we would like to disclaim that we don't endorse any particular brand or any particular manufacturer, and we represent the fluid conveyance world especially. FCP Index team welcome you all. And it's an FCP Index. It's a expansive and well-tuned and conscious support engine. It's a initiative started by a few of our technocrats visible in the screen. You can see, and for it is a tailor-made to suit the Indian subcontinent. We are a team of professionals with wealth of experience in the fluid conveyance industry, especially hose and fittings. We have worked with all the multinational brands, most of the multinational brands like Dunlop, Eaton, Gates, and Parker. The key objective is to uplift the hose and tube assemblers from growing or marginal player to a global player, providing them assistance on information and techniques on quality products and system that meets international specifications. These all are beneficial and most durable products and assemblies to meet the international requirements to the customers. What we do for the FCP community is we assess their facility and we see for the optimum shop floor layout. Then we support on selection of right hose assembly machines, tube assembly machines, support on getting correct spares and accessories for machines, assistance on procurement of hoses, end connections, dressings, tubing, seamless tube connections, etc. Then more important factor, operator training, which is one of the biggest hurdle, Pokayoke, fail-safe plans, training on hose assemblies, contamination control, maybe one of the subject we are discussing today, basic and advanced hydraulic training, which is also necessary to understand the basics, effective safety practices, and a complete training on safety methods, practices, methods, products, and practices. Then technical assistance on components, drawings like hose fittings and all other child parts, end connection standardization, its codifications, drafting and implementing order process form, job route card, etc. Then drafting and implementing standard operating procedures, work instructions, safety plans, process flow, then identifying the skill matrix, assistance in achieving management system. Those most of you are certified in ISO 9001, but again ISO 14001, 45001, then IATF, etc. We also support, our patrons. Maybe we are describing the subscribing program also. We are supporting with them to clear the stockpile, what they do have, the dead inventory, what we call in common, e-procurement tenders globally and especially on Indian subcontinent, Then FCP Times, we are coming up with a magazine called FCP Times with the latest information on projects and products. Then latest methods on techniques on hose and tube assemblies. Then global survey report on hose assemblies, fittings, hydraulic fittings, etc. The basic agenda is, to connect the unconnected. What we say, to connect the unconnected. There are about 75 plus hose manufacturers, 1100 plus hose end connections manufacturers, 125 plus hose assembly machine manufacturers, 50 plus hose machine spare manufacturers, around 22,500 hose assemblers across India, 240 plus hydraulic fitting manufacturers, 55 plus seamless tube and related tube manufacturers, 95 plus dressing, what we call as spirals, fire sleeves, whips, etc. And many more. Say in coming days, they say declare that this is a contact detail. From it is happy to announce that from 10th of this January onwards, we are relocating to a place called Pride Purple Square, and the details shall be shared very soon. Thank you. Thank you all. Now, Prakshi, please.
Thank you, Anup, sir. Now, I would like to introduce the speaker of today's technical webinar, which is Mr. Krishna Kulkarni. Mr. Kulkarni is a seasoned professional having experience of 32 years in installation, commissioning, maintenance, troubleshooting, and repair of hydraulic components and hydraulic systems. In his career spanning more than 3 decades, Mr. Kulkarni has worked in renowned organizations like L&D, Eaton Fluid Power, Bosch Rethox, and Moog Hydraulics. He has undergone hydraulics training in Linde, Germany, SAI, Italy, and Moog Control, Japan. He has conducting fluid power training programs to various mobile and industrial hydraulics customers across India. Mr. Kulkarni is a council member of Fluid Power Society of India, Pune chapter, and a member of International Fluid Power Society, USA. Now, I will request Mr. Krishna Kulkarni to start today's session, which is on the importance of fluid cleanliness in hydraulic system. We will have a question and answer session in the end of the program. You can write your questions in the chat box. Thank you and have a great session ahead. Over to you, Krishna, sir.
Yes, thank you very much, Prakshi, for that quick introduction about myself. It was really nice hearing to that.
Thank you.
Good afternoon, everyone, and welcome to today's session on the webinar series. So I will just take you through the presentation. Yes. So I hope my slide is visible to everyone.
Yes, sir.
Yes. So welcome you all once again for this knowledge sharing series of webinars, the technical webinars. So today's topic being fluid cleanliness, the prime importance for hydraulic systems. So I'll take you through the contents for today's presentation. To start with, we'll have a brief introduction about fluid conditioning. Then we'll understand about the fluid properties, the different types and sources of contamination that we need to deal with, then the amount of contamination that we encounter with the new hydraulic fluid, different types of contaminations, that is built-in contamination, induced contamination, ingress contamination, internally generated contamination, what are the different types of fluid conditioning that we do, what are the different type of filter elements that we use in order to do the fluid conditioning, methods of filtration, sorry, and last, fluid sampling and testing. Right. So as we all know, fluid is the heart of any fluid power system. Like because our transmission we do, we are basically converting one form of energy to another form. So it could be the electrical energy or the thermal energy that using the engines that we talk about. And yes, we convert this energy into mechanical energy through the fluid as a medium. Okay, so fluid has a very important role to play as far as the hydraulic systems and pneumatic systems are concerned. So today we'll be discussing more about the fluid cleanliness with respect to hydraulics. So as we all know, majority of the failures that we encounter in a hydraulic system is mainly because of contamination. So just to give a number, about 75 to 80% of the failures are mainly because of the contamination. So what is the impact or the consequence of having this contamination in a fluid power system? Let's try to understand that. So this has a direct impact on the reliability of the system. So if your fluid is not very clean, so it will certainly affect the performance or the reliability in performance of the hydraulic system that you're using for. Okay. Apart from that, contamination also affects the life of various components that we use in a hydraulic system. To start with, it is the pump, then we have the control elements, then we have the actuators. Okay, so these are the main components that we talk about when we use a hydraulic system. Then of course, since some of the components get affected, the consequence or the impact of this will again get extended to the life of the system. So overall, as long as your fluid is clean, then you can expect a higher life expectancy in the performance of your hydraulic system, else it is certainly going to deteriorate. Okay, so how do we compare a fluid of a hydraulic system with the human anatomy? To put it very simple, it is like blood of a human body. So it is the blood of a hydraulic system, we would say. Okay, so as we all humans consider the blood to be very important, the same way we need to consider the fluid also to be equally important as far as the hydraulic system is concerned, because it acts as the blood of the entire system. Okay. So what other reasons are there for the contaminations? Contamination deteriorates the life of the components. Yes. So how it deteriorates, we have different type of particles, which probably I will discuss in the subsequent slides. So that will definitely deteriorate the life of the components in different forms. It also accelerates the fatigue. So the fatigue means basically life of a component. So if it is more contaminated, then the fatigue failure will be much faster. Okay, it degrades the performance. Yes, certainly, because when we say performance, we talk about the efficiency of the hydraulic system. Okay, so it certainly is going to affect that, right? And it also leads to malfunction. Yes, there can be an erratic behavior of your system, or it may not operate to the expected levels. So anything in short of the expected performance is called as a malfunction. Okay, or if you're not meeting a desired function, then we call it as a malfunction, and that can happen because of presence of contaminants, which can lead to malfunction of any of the components, which in turn will get affected to the malfunctioning of the entire system. Okay, so presence of contaminants also degrade the fluid, because when we talk of contamination, we talk of different contamination. So it can be in the form of a solid particle or a liquid, in liquid form, in solid form, liquid form, or even gaseous form. Okay, so this is very, very important for us to understand. Okay. So before we proceed further, we need to understand what is the importance of the fluid. So what are the properties of the fluid that we need to consider? Okay. So as I mentioned to you, the main purpose of the fluid is to transmit the power. So power transmission is one of the key factors that we need to consider when we talk of this particular fluid. Okay. Then comes the sealing. When we say sealing, that means the fluid itself should act as a sealing agent, so that it doesn't pass through the clearances and then in turn affect the efficiency or volumetric efficiency of the system. Okay, so power transmission is key, because that is the purpose for which it is being used, because that itself is acting as a medium. So that's one of the very, very key factors of the power transmission. And similarly, sealing means the desired fluid should be in such a way that it doesn't leak out easily through the clearances. Now we talk about why sealing is important. We talk about various components. Let us say we talk about a pump, a piston pump, for example. So the piston is supposed to reciprocate within the cylinder block or the bore, and there has to be some clearance. There cannot be an interference fit. So there has to be a need to have clearance between the bore as well as the piston. But at the same time, doesn't mean that the clearance should be good enough to pass the fluid through it very easily. So the fluid property with respect to sealing should be in such a way that it doesn't easily leak out of the clearances that are there in various components or the system. Next, most important is lubrication. So as we all know that we have the metal to metal contact on various components, and so that will that can lead to friction. So lubrication is must. Lubrication property is a very, very important property of the fluid that we need to have, so that the friction generated is kept at the minimal most levels. Okay. Next is cooling. Yes, the fluid should have a good cooling property. That means the heat dissipation factor should be very good, so that the heat is taken off. Okay, so when we say heat dissipation, it can be heat injection also in some of the cases. So in short, we call it as basically the exchange of heat, whether you want to take it out or whether you want to inject, because in some cases in the cold countries, we also have to inject. So it should have the property of cooling as well as heating, but cooling is more prominent because higher the temperature, yes, we have the impact of that on the performance of the system, wherein it affects the volumetric efficiency of the system. Okay, it should also have an excellent property of contaminant removal. So what exactly do we mean by this? So this means we need to understand that the fluid that we use should be compatible to the filter elements that we use. So it should be good enough in passing through the filter elements and thereby helping the contaminants to get trapped in this particular filter element. So this is again an important property of the fluid. So these are some of the key properties that we talk about, starting with the power transmission, then the sealing, lubrication, cooling, and then contaminant removal. Okay. So moving on to the next, what are the different types of contaminations that we have in a hydraulic system? Okay. So as I mentioned, the contamination can be in the form of solid particles, or it can be in the liquid form, and it can be in a gaseous form, or something like gel-like contamination can also be there, which is called as sludge. Also, we can have that kind of contamination. Now, how do we define contamination? What is contamination? Now, can we eliminate the contamination 100%, or it should be completely contamination free? No, but the definition of contamination is something which is beyond the expected level in the fluid is what we define it as contamination. So we cannot eliminate the contamination 100%, but we can always limit it to an extent so that we get the maximum efficiency or maximum life of the components as well as the system, and well, as far as the best performance and the best efficiency of the system overall. Okay, so let us try to understand some of the types of contaminants that we generally encounter in the fluids. We have the non-metallic particles. For example, we talk about the dust, swarf, sand. All these are non-metallic particles which are generally commonly found in any fluid. Okay, now what are the means through which these things can get in? We'll try to understand it later, but these are some of the examples for the non-metallic particles. So what about metal particles? Yes, it can be metal particles, it can be steel, it can be brass, or any metallic particle that is being used for either manufacturing the complete system or the component or the accessories that we use or the fluid conveying components that we use, or it can be even self-generated particles that can be there. So these are the different type of aluminum particles, brass particles, some sintered particles, then steel, of course, then cast iron particles. So these are some of the particles that are generally found in the as contaminants in the fluid. Okay, so we classify all these under the metal particles. So yeah, so it can be even water, because as we all know, we use the petroleum-based fluid, which is used as the fluid medium, the most commonly used. Hence, water is generally not compatible with these fluids. Okay, so the most common thing that we see when the water gets mixed with the fluid is it starts becoming milky. Okay, so that's the first indication that we encounter with. And yes, there is always a certain amount of percentage that is recommended, but if it exceeds beyond that negligible value of percentage, then it automatically starts becoming milky. So that is why even water is not permissible in the type of petroleum-based fluids that we use. Of course, there are certain fluids where water is emulsified along with the fluid, such as the fire-resistant fluids and all those things. Yes, there it is acceptable, but then this has a direct impact on the life of the components. So as we all know, we use the ferrous components, which when it comes in contact with the water, it easily oxidizes, and we have the corrosion or the rusting that happens on the various components. So that is why water is not a compatible one as far as our fluids are concerned. So we consider water also to be one of a type of contaminant, as one of a major type of contaminant in the form of liquid. Okay. So then we have the sealing materials. So we have different sealing materials that we use in a hydraulic system to arrest leakage. Okay. So it can be the seals. Okay. It can be certain sealants. It can be a Teflon tape. So it can be some other rubber component. Seals, when I say, it can be a static seal or a dynamic seal. So now over a period of time, when these are subjected to operations as well as a certain amount of temperature, certain amount of duty cycles, and all these things have a certain life. And as the life starts deteriorating, then it starts breaking up, and these broken particles will get converted as contaminants and get mixed up with the fluid. So it's also equally important to understand on this. Okay, this we classify under the non-metallic particles also. Okay, so then we have certain acids and chemicals which are either either they get ingressed during some of the cleaning processes that are associated, or else by the reaction of the properties of the fluid due to which these things get generated. Sorry. Okay, so then again, corrosion is again one of the main reasons. So we can see the rusted particles also in the form of contaminant in the fluids. Okay, so this is because mainly the component getting oxidized, and which will lead to the corrosion or the rusting. So what are the different sources of contamination? So how does this contamination get into the system or the fluid? Okay, so it can be because of the new hydraulic fluid. Yes, new hydraulic fluid also is not absolutely clean. We'll try to understand how exactly it is. And then it can be built-in contamination. Then we have induced contamination. We have ingress contamination, and we have self-generated contamination. New hydraulic fluid means, as we all know, the fluid that we use is petroleum-based fluid. So where do we get this oil from? Where do we get this fluid from? So we need to understand. So it is a product of the petroleum industry. So the first thing is the oil is basically taken out from the sources available. So we have the oil wells through which it is taken out, and then it is sent to the refinery. So where it undergoes different processes, and then it is stored in large storage areas, and then it is being stored to moderate areas. Then the packing is done, the barreling is done, and then even small packagings are done. And then these packagings will handle the are handled by the hydraulic system operators. So wherein they pour this oil into the hydraulic reservoir or the tank. So these are the different stages through which the hydraulic fluid is generally handled. So that is why the hydraulic fluid that we use will not be absolutely clean. Okay. So built-in contamination. Built-in contamination is generally this occurs during the manufacturing or the assembly process. We'll try to understand about this in detail. Induced is again when we, let us say, we do some maintenance or do some service or repair at that point, it may get induced. Ingress is contaminants getting through the external sources, okay, so or through external media or the environment that we talk about. And then we have the self-generated contamination, where we have the internal contamination generation mechanism for these by the components which gets into the fluid. So how does it so how do we understand about the new hydraulic fluid contamination? So it may not be very clean as we assume. Okay, so now when we talk of hydraulic oil, we may say, okay, the oil looks very clean, but that looking clean or the appearance to be clean, it doesn't mean that the oil is really clean. So what is important is to understand, as we understood in the earlier slides, what form of solid particles are there, what type of liquid is ingressed, then what are the type of gases that are present in this particular fluid. So all these unwanted things, it could be chemical, water, or some gases, or solid particles in the form of metallic or non-metallic things, and all these unwanted or which are beyond the limit are not required. So it is certainly present because, as I mentioned just previously, that yes, the oil fluid is being handled with various stages. So now all these stages will come into picture, and every stage it is handled, there is always a room for the contamination to get ingressed or induced into the fluid. So the more the handling process, the higher the level of contamination will be. Okay, there are certain manufacturers who also give a certain standard of the grade of oil. They say that yes, it has been purified to a certain level, and then it is supplied. Now, generally, when we talk about the cleanliness of the oil by vision, that is looking into our visibility, a good eyesight of a human being which can see the smallest particle is about 40 microns. Okay, so just by looking at the oil and saying that there are no particles present, I mean, we may not be actually able to count it with our naked eyes, but when we talk of taking a sample, we take the sample and then try to count the contaminants present in 1 ml of the fluid. So we can imagine now we are talking about 40 microns. What about the particles which are smaller than 40 microns then? Okay, if it is something beyond, when we say visibility by the naked eye, it is without using any aid to the eyes. Okay, that means not the specs or not the magnifying glasses and all those things. Okay, so this is what is important. So generally about 40 micron size particles is very commonly found in the new oil that we take about. And what is the cleanliness level that these people follow? So if we talk about ISO code 2119 is the generally recommended one. So we are talking about the 5 microns and 15 microns here. So if you say 5 microns, 21 corresponds to, let us say, about 10 to 20,000 particles present in 1 ml of the sample. And similarly, 19 corresponds to, let us say, about 2.5 to 5,000 particles per ml of sample. So this is what is the criteria that is given. So you can imagine what is the amount of particles that we can find under this ISO code. Okay, but this ISO code is generally defined or recommended by the manufacturer, which probably we'll discuss in the subsequent slides. Okay, in detail. So what is the permissible content of water? That should be about 200 to 300 parts per million. So that is the thing that we need to have. Then oil transfer units are supposed to be used, not just pouring the oil directly from the barrel, but you can use an oil transfer unit. And yes, there can be when we use the oil transfer unit. I'm sure those. Okay. And as I mentioned, there are certain pre-filtered fluids which are available, but whatever grade is specified, it's always good to get a sample testing done before we pour it. Or if not, in over and above that, we can always use a filtration unit, oil transfer unit, along with the filtration. So that will help us in transferring the oil as well as filtering the new oil to a certain good level or the acceptable level for the hydraulic system. What are the different types of built-in contamination that we generally see in the fluid? Now, if you see the details here below, we can see that the manufacturing and assembly process generally adds on to certain contamination. Okay. Now, when we say manufacturing, yes, we manufacture the complete system. So in the process of building the complete hydraulic power pack or assembly of components handling, so in this process of manufacturing as well as assembly. So when we say manufacturing, it can be, we can say it is more of manufacturing of the components and manufacturing of the power unit. That is how we can put it. And assembly, of course, again, it is referred to as the assembly of the components as well as assembly of the complete power pack, okay, or the power unit. So these are the areas where the contamination can get easily added. So a lot of precautions have to be taken in this particular process of manufacturing and assembly. Okay. Then comes the machining operations. A simple example that I would like to quote, and of course the power pack or the power unit that we manufacture is also machined. So any residue of that machining operations, if it is left out, it is considered as a built-in contamination. Okay, so it can be like the drilling operation or some grinding operations. So all these things can lead to some residue of the uh, machining operation or the process that we carry out. Okay. The most important is fabrication of the reservoir. Yes, we do the welding part for building the reservoir or the tank, and this is one of the key areas where we really need to look into, because the residue of the welding process can be left out, which is pretty common, and that again becomes a built-in contamination. Apart from this, while handling by the concerned technicians or the supervisors who are involved in the process of manufacturing and assembly of the components and the systems, there can be rags which are used for probably for the cleaning process, and the broken tools, for example, the broken drill bit, we can say, then some chips, let us say chips that are left out after machining in a manifold block, etc. So all these things are quite common. If a manifold block is not thoroughly cleaned, and if some chip is left out, probably that gets carried away when the manifold block is subjected to flow and pressure in that particular line. Okay, pressure of course helps in pushing the component very easily. Let us assume if it's a return line, the velocity of the fluid should be good enough to carry those chips or broken components, which may get further into the system and may hamper the functionality of a particular component or a system as a whole. Okay, hose, pipe, and tubing is another very critical area, because hoses are again assembled, and in the process of assembly, the hoses are cut. So when it is cut, generally we have we have seen the construction in our previous webinar. Okay, so these particles of the cut hose can get into the hose in the process of assembly. Plus, we also have the skiving operation that is done on the hose, and then we also assemble the end connections. Okay, so all these in the process of building the hose, it can carry some contaminants also. Piping and tubing, yes, again we can see a lot of scaling that occurs in the pipes and tubes that we use, and let us say we do the deburring activity and all those things. So these things have to be cleaned thoroughly. So, okay, so especially if it is piping, we carry out the process of pickling and acid cleaning. So in the process of pickling and acid cleaning, also the contaminants may get there in the form of solid or liquid contaminants. Okay, and that can hamper the system. Fittings and connections, very important. So we have to take adequate precautions when we store the, yes, another important, when we say the manufacturing assembly, the handling and storage is also part of this particular built-in contamination. So whatever handling we do, we need to handle it in such a way that it is never exposed to the atmosphere or other particles. Okay, so adequate precautions have to be taken care, and even while storage, it has to be stored in such an area where again it is not exposed to a dirty environment. Okay, so and assembly and of fittings and connections, we need to take precautions, else that can, any damage to these fittings and connections can lead to the contaminants again getting ingressed into the fluid. Then sealing material, yes, as I mentioned, it can be because of some seals which are improperly assembled, and it can get damaged, or it can get cut, or it can get skived, and that will enter or get entrapped as a built-in contamination. Apart from the seals, we also use certain sealing material like Loctite or even the Teflon tapes. Now all these things can come in the form of residue, and it will become a built-in contamination to the system. Okay, so these are some of the types of built-in contaminations that we generally encounter in a hydraulic system. Induced contaminations. Now, when we say induced, what exactly do we mean by that? Inducing means that in the process of operation, it is getting in through an external source. Built-in contamination is internal. Built-in contamination is in the process of operation, and induced means it is through external sources. Okay, so that means whenever you are doing the maintenance of hydraulic system, generally there is a possibility that in the process of carrying out the maintenance, for example, let us say a quick example of replacement of a filter element. Okay, so if you have to replace a filter element, obviously the filter assembly has to be opened up. Okay, now how you open it up, in what conditions you open it up, how do you keep it during the process of disassembly, how do you then handle the filter element, the clogged filter element, of course, has to be kept aside, but how do you handle the new filter element, how you would have stored it, and what precautions you are taking during the assembly. That means right from disassembling of the filter assembly till placement of the filter element, and again reassembly of the complete thing. So similarly for maintenance, let us say you're topping up the hydraulic fluid. So what is it that you are doing? How is it that you are handling the fluid? When we talk about a heat exchanger, how is it that, let us assume that there is a scaling that has occurred and the efficiency of the heat exchanger has gone down. So we generally try to descale the, let us say if it's a shell and tube type of cooler, then we try to descale it. So when you open up a heat exchanger, how do you handle it? What are the precautions that you take? So all these things will matter. Similarly, when we talk about service, whenever you do the servicing of any system, so what precautions do you take? Okay, so servicing means, let us say you want to replace the seals. Okay, so, or let us say you have a periodic schedule for taking out a component and again checking out on the seals and again reassembling and then putting it back into operation. So in the process of right from disassembly of a particular component till you check it out, then make the changes and then again reassemble and then put it back again onto the machine. So in this entire process, what is it that you have taken care of? So that is what we mean when we talk of the service. And similarly, repair. Suppose if a component is damaged and you have to repair it, so how do you do it? So what precautions you take in while repairing? So you have to always ensure that the parts that you're going to replace are stored properly, and the parts are opened up only at the time of assembling onto a particular component. And the repairs also always have to be done in a clean room, which is free from the dusty environment or environment that can hamper the component. So that should not be the case. So it should always be a clean environment or clean room that we call it as. Okay, so all repairs have to be done there, and then the repairing activity has to be carried out. Rebuilding of the components, yes, we also suppose if life of a component has come down, then probably we can again renew it or rebuild it by replenishing with new components which can make the component as good as new. For example, a pump, let us take, we say that okay, we can replace the rotary kit and it becomes as good as a new pump, because accepting the case and the end cover, rest of the components are new in that. So in the process of rebuilding, again, if you're not handling it properly, then there is always a possibility that the contamination can get induced into the components during this process, or it can be even rebuilding of the complete power pack also. Okay, so whatever precautions you take during this process is really what matters. Okay, high pressure wash. When we say high pressure wash, generally this is to clean the equipment or the machine or even the power pack at times. Okay, so the actuators are mounted on the equipments of the machines, and power pack is also kept in a separate area. And in the process of washing, for some reason, the water can get induced in the process of this high pressure cleaning or washing activity. So we need to take precautions wherever there is a possibility of an opening, or wherever there is a possibility of the water getting induced as a contamination into the system. So we have to be very, very careful on this aspect. It is a quite common thing, especially whenever you have the cleaning activity. And yes, you need to cover certain part of the components of the system through which the water can get induced. Okay. So adequate precautions have to be taken care there also. So coming to the next point of ingress contamination. Now there are different type of contaminants that get ingressed into the system. Okay, it can be through directly into the reservoir. It can be through some of the components also. Okay, so the ingress type of contaminants, generally we have the airborne dirt, which is the most common one, and this is very, very common, especially if it is working in the open environment, because there it is more prone to exposed to the dust. Okay, and which is the key component through which this airborne dirt can get ingressed into. So it is always the air breather that we talk about. Okay, so generally we have to have a proper micron rating of air breather. Generally about 2 to 3 microns is 2 microns or 3 microns is the rating that we talk about. So it can hold particles beyond these ratings. It can hold the particles beyond those ratings. Okay, and then comes the moisture. Yes, this is again another key thing, because the moisture gets in, then because of condensation, what happens, it gets converted into water, and the water gets ingressed into the reservoir. Okay, so this is again has to be taken care. So in case if you have a humid climate or a humid environment where the power pack is kept, then generally we need to have the silica gel type of breathers, which will prevent the entry of moisture, because that moisture is absorbed by these gels and the dry air is being transmitted into the reservoir. Okay, so that helps in preventing the moisture getting in. Then we have the chemical pollutants. Okay, chemical pollutants, again, it can be a hazardous area where the system is working. So it can be again through the breather only, because breather getting the solid contaminants is one part, then the moisture is again another part. Similarly, a type of chemical or gas that is present around where the system is getting operated, so it can get through that also. So those chemicals or gases can be contaminants, because they are unwanted gases or chemicals that are as far as the fluid is concerned. So it can be again the chemicals and the gases as pollutants. Okay, so microbial life and the media that we use, so it can be some of the microbial life also can get entered into that. Okay, industrial pollutants, again, as I mentioned, something pretty close to this chemical pollutants. So now this can be in any industry where there is a lot of pollutants because of the industrial process that it handles. So if the power pack or the components are exposed to this, and if there is a possibility of it getting ingressed, then again it is considered as ingressed contaminants. So then the pollens can also enter through the breathers. So pollens are again other form of contamination that can get ingressed into the system. So these are the different type of contamination that can get ingressed into the system. Okay, ingression is one part, but where do they get? Most of the time I spoke about the air breather, but are there any other areas where, apart from the air breather that we talk about, that these particles can get ingressed? Yes, one area is key area is the linear actuator, that is the hydraulic cylinder, which is the hydraulic, the rod of the hydraulic cylinder, which is always exposed to the atmosphere or the environment. So whenever it is getting retracted, there is always a possibility that contaminants which are settled on the cylinder rod can get carried away into the cylinder and then getting mixed with the fluid, and then from mixed fluid into the reservoir. So this is quite a possible thing which can happen on most of the linear actuators. But when will this exactly happen? Don't we have a wiper seal there? That might be the question. Yes, there will be wiper seal, but wiper seal also has a life. Suppose if it wears out, then what happens? Then it cannot hold or resist the contamination. Okay, initially it could be smaller components, smaller contaminants, and as the wear and tear increases, it can lead to ingression of much larger particles or contaminants. Okay, so that is one area. And another area is on the shaft seal. We can see the a pump here, and we have suction port on the shaft end side. Okay, so now since the suction port is, we need to understand if something is going in, that means there should be a differential pressure that will happen, because of which the pollutant which is present in the atmosphere can get into the component or into the system. So that means the pollutants get carried away because of the differential pressures. So that means the areas where generally, of course, in case of air breather, it is pretty much clear, because the atmospheric pressure being greater than the pressure on the pump inlet side. So naturally, there is always a room for the air to get in easily. So it gets carried away along with the air. What about the cylinder then? Cylinder, yes, that is not because of the differential pressure, but because of the path available for it to, because it's leaking. I mean, the seal is damaged. We can see that. You can see the leakage of the oil to the rod end. So that is one area through which it can get entrained or get ingressed. Similarly, in the suction line, what happens? The pressure is lower in the suction line as compared to the atmospheric pressure. So if the shaft seal of the pump fails, the shaft seal area is now connected to the suction chamber of the pump, because of which what happens, the pressure being lower on the suction chamber as compared to the atmospheric pressure. So it is always, if the seal is damaged, shaft seal is damaged, it can get ingressed through that part also. Then comes your suction port itself. Suppose, for example, the sealing is improper or incorrect on the suction port. There is a room for the air to get in. Okay. And similarly, if the connections or the fittings which are used on the suction port, if they are not intact, or if they have not been tightened properly, so there is always a room for the leakage to happen. When you say leakage, it is not the leakage from inside to outside, but it is from outside to inside, because of the differential pressure. Internal pressure being lower side and outer pressure being on the higher side. Okay. So these are some of the types of ingress contamination that we see, and locations through which it can get ingressed into the system. Internally generated contamination. Yes, this is again one of the most important. Now, internal generation of contamination can happen because of wear and tear of the component. Okay, and it can be also because of the fatigue. So wear is very well known to us, because over a period of time, if a particle, if a component is, or if a part of a component is being subjected to a movement, and because of the friction between the mating component, it can always lead to wear out of the surface area. Okay, so that is one important aspect. And the second is the fatigue. Fatigue means if a component is subjected to let us say continuous pressure or continuous force that is acting on a particular area, what happens? That particular surface area can get weakened. Okay, so every component has a life. Every component has a life, but there are always clauses that it is subject to so and so. So there are various things. So pressure is one among them. It can be the flow, it can be the duty cycle, it can be the temperature. So it can be the sudden changeover of the loads, or it can be the pressure spikes. So various factors will matter on the fatigue. Okay. But fatigue means, yes, every component has a life. Okay, so anything that works in this world always has a life. Okay, so then we have the fine particles. Yes, fine particles, what is it that they do? Fine particles, when we talk about, they are nothing but the silt particles. Now, silt particles, when they're traveling at, let us say, a high velocity, what happens? They come in contact with the surface area of the components when they're passing through the clearances between the surface areas of those particular components. Okay, but in the process of they getting transmitted along with the fluid, because of the velocity, what happens? These silt particles may come in contact with the surface areas of the mating components. Okay, and they will damage the surface area. Okay, so that is how these fine particles are equally dangerous. Now, when we talk about the type of particles, generally we have we classify them into three types. One is the fine particles, which are nothing but the silt particles, which we discussed and understood how it is going to impact. The second one is the particles that are pretty much closer to the size of the clearances. Pretty much closer to the size of the clearances. Like we see the biggest particle here, but it is pretty much close to the clearances of these two components. Okay. So in the process, what happens? It may damage the surface areas on both the sides. It may damage the surface areas. One area for sure it will damage, and if the clearances or because of the shape and size, if it gets changed and if its position gets changed, and it may even get stuck also. Okay, and in the process of moving, it may damage the surfaces on either side also. Okay, or it may get stuck. Then comes the third one, which is greater than the size of the clearances. Greater than the size of the clearances. So will it really hamper the performance is what is important. But here what we need to understand is, for example, we're not talking only about the clearances. Okay, we are also talking about the small holes or orifices which are present in the system for various components. Okay, now these larger particles may just go and block in that particular passage. For example, let us say it's a pilot line or a small leakage line. So then what happens? The path is blocked. If the path is blocked, what happens? It has a consequence. Either the system or the particular component will not function at all. It will not operate at all. Okay, or at times it may operate, and at times it may not operate. So that means intermittent operation or no operation. So that can happen. Okay, so this is very, very important for us to understand. And degradation of seals in the elastomers. Okay, we use a lot of seals and elastomers, which are both static as well as dynamic conditions. So they have a life, as I mentioned, and that life is depending on various factors. It can be because of the pressure it is subjected to, because of the temperature it is subjected to, because of the velocity of the actuator that it is subjected to, or the wear and tear it is, the duty cycle that it is subjected to. So all these factors can affect the life of the seals as well as the elastomers, and over a period of time these may get hardened, and then it may break away into smaller or finer particles and can become internally generated contamination. Okay, aeration and cavitation is one of the most important phenomena that occurs in a hydraulic system. It is considered as the next highest source of contamination in a hydraulic system. So we have to be very, very careful as far as aeration and cavitation are concerned. So we did understand that about 75 to 80% of the failures occur because of contamination. Okay, so the next 10 to 15% of the failures occur because of aeration and cavitation. Okay, so this is very, very important. Now, of course, we don't have, we are not going in detail about how the process or the phenomena occurs, but the phenomena of aeration and cavitation are pretty much identical. Okay, and in both the cases, there is a formation of microjets either because of air or because of the vacuum, and these bubbles, when they go and hit the surface areas from where it is coming out, will have a very severe impact, wherein the bubble will implode and it can create pitting marks, and thereby it will damage the entire surface. Okay, so now that pitted particle will get into the system as a contaminant. So that is why this is very, very critical and important. Rust and corrosion, yes, very important point again. So the surfaces, if they get oxidized, the scaling of the corrosion will lead to the particles getting in. Okay. Then comes erosion. Again, this phenomena can occur because of the oxidation or subject to some other chemical contamination that is present in the components of the system, which can lead to the erosion of the surface. Okay, or this can be even because of the particles hitting onto the surface area frequently on a particular area, and that particular area will become fatigue, and then it may give away or it may chip off. Okay, so that is where this erosion is very, very important. So what are the different types of conditioning we talk about? What are the different types of conditioning that we talk about? Okay, now, so we talk about particle removal, we talk about the air removal, we talk about the water removal. Similarly, we talk about and then we talk about the heat also. Okay, so particle removal, yes, we need to have the filter particle. As we understood, we have different type of whether it is induced or ingressed or built-in forms. Any of these three forms, it can get in. So that has to be taken care of. So whatever mechanism we have in conditioning of the fluid, we need to ensure that particle removal is also one of the key ones. Then comes the silt removal. Again, this is pretty much similar to the particle removal, and the silt also has to be removed. Air removal, because that can lead to aeration. So air removal is again another important point. It can be air removal or even some gas removal also. So we need to have a arrangement for that. Not a very common one. The most common one are the particles and the mainly the particle removal that we talk about. Okay, and the water removal is there, but that's a very negligible value because the type of filter elements that we use are generally not compatible for removal of the water in most of the cases. Okay, but if there is something specific, if the customer has understood about the environment under which their system is working, so probably they may ask us to recommend for giving an appropriate filter element for that kind of fluid conditioning. Acid, sludge, and chemical, as I said, this is because of the ingressed condition, okay, or sometimes even built-in condition also. So those things will affect the properties of the fluids. Now, one important aspect, most important aspect of this fluid conditioning is to understand what is it that we are getting rid of. Okay, so one is with respect to the presence of the contamination in a physical form, be it solid, liquid, or gas. That is one part. And second thing is bringing back the properties of the fluid which has got deteriorated back into its shape. Okay, so that's again very, very important. So basically we classify into two types. One is we talk about removal of the particle in a physical form, and the second thing is reinforcing the properties of the fluid, okay, or at least understanding the conditioning of the properties so that the properties doesn't get deteriorated, and which in turn should not affect the performance of the fluid. Okay. So as we can see here, I mean, just an example, we can have a combination of conditioning unit which will take care of that. Heat removal, yes, heat is also considered as a contaminant because it is not, if the temperature is exceeding beyond a certain level, then certainly it is going to affect the properties of the fluid, which will have a severe impact on the performance of the system. Okay, so heat removal also is equally important, or heat removal is also part of the fluid conditioning. So we need to have a heat exchanger, right? So what are the different type of filter elements? Let us try to understand on that. So basic classification is mechanical filters, okay, which we talk about generally we talk about the mesh type of filters. We call it as mechanical filters, or some simple mechanical element that is there for a certain amount of grading. That is what we talk about generally. Then comes your absorbent filters. Absorbent filters are the types, okay, basically which will remove the particulates, and some amount of free water is also removed in this. Okay, so that is what we call it as absorbent. And then we have the adsorbent. Adsorbent will generally remove the free water. Okay, and the oxidation byproducts, like we discussed about the acid, sludge, and all those things. So all such things, it can also be removed using the adsorbent type of filters. Okay, now this is as far as the typical construction or the type of material that is being used for the manufacturing of the filter elements that we talk about. Okay, in general. Okay, apart from this, how do we classify the filter elements is with respect to its ratings. Now, what are the different type of ratings under which we get the filter elements? Now, the most common ones are the nominal rating, the absolute rating, and the beta ratio. Now, when we talk about the nominal rating, what exactly do we mean by nominal rating? It's a particular size in terms of micron. Let us say a 5 micron nominal filter or 10 micron nominal filter that we talk about, but it's more of a micrometer size, which is not a very common one that is being used currently. Okay, it's basically an arbitrary micrometer value that we talk about in this particular type of nominal filter elements. Okay, and because of the lack of the reproducibility of these filter elements, it is no longer a very popular one in the industry. Okay, next comes the absolute filtration rating. Absolute filtration is basically means we have a particular size, let us say a 10 micron filter element, 10 micron rating filter element, wherein the spherical size of the component that the element can hold would be equal to or greater than 10 microns. That is what we talk about, or greater than 10 microns that we talk about. But if the, let us say if the particle size is smaller than 10 microns, and it may not be spherically of the same size, but if the length of the particular component is more, then what happens? Then it can pass through. So that is what the absolute filtration means. Okay, like for example, let us say you're having a 25 micron filter. There is a presence of a thread which has a diameter of about 20 microns, let us say. Now 20 micron thread has a diameter of 20 micron. So spherically we can consider it to be about 20 microns. But what about its length? If it is, let us say, 20 mm in length, no, it will never hold. Okay, so that is what it exactly means here. So that is what is absolute filtration rating. Then we come to the beta ratio. Now, what exactly do you mean by beta ratio? So when you talk of beta ratio, it is mainly the ratio between the number of particles on the upstream side divided by the number of particles on the downstream side. Okay, so that means we have some set of known contaminants and the known value or the quantity of the contaminants being fed into a filtration system. and we count the number of contaminants that we have poured in, and then we try to measure it on the upstream side as well as measure it on the downstream side. Okay. Now let us say you have poured about 1,000 particles, out of which the filter element has held about 500 particles. Okay, and that means it's about 50% efficiency. That is what we talk about, because you poured 1,000, it has held about 500. So that is how we try to arrive at. So this is what is called as the beta ratio filtration rating. Okay, so it's called as a multi-pass filter test. So based on that, this particular beta ratio is being used currently, which is the most popular one that we are talking about. Okay, next comes our methods of filtration. What are the different methods of filtration that we talk about? Yes, we have different locations for these for placement of the filter assemblies, and these locations are basically the most common one that we see in any system is a return line filter. Okay, it's a return line filter. Then we talk about the pressure line filters. Then we talk about the suction line filters. We talk about the offline filters. We talk about bypass line filters, and then we talk about the batch process and reclamation. Okay, return line is the most common one. As I said, whatever the flow is coming out. So here we can see this one is your return line filter. Okay, so whatever fluid goes from the pump into the system and then returns back to the reservoir. So much before returning to the reservoir, we try to filter it and then hold the contaminants back in the filter element, and then release the fluid back into the reservoir or the tank. Okay, so that is what is your pressure, return line filter. Then we have the pressure line filter elements, or the filtrations or filter assembly. So these pressure line filters are basically used wherein we have critical components, like for example, we have a proportional valve or a servo valve, where the fluid cleanliness becomes more stringent. Okay, so we have the conventional systems, then we have systems which operate precisely, then we have systems which operate much precisely using the electrohydraulics, that is using the proportional valves. Then we have much more critically operated systems wherein they use high frequency response servo valves, and there it becomes much more critical. So as you go up the level of the technology, you have to be more stringent as far as the cleanliness level is concerned. So this is with respect to why this happens, because greater the precise performance that you are expecting, greater will be the precision that is used in the components that you are utilizing, or that is being used for achieving that kind of a result. Okay, and when that happens, then the cost also will be very high. Now, if the cost is high, and if you don't maintain the, let us say we talk about a servo valve which may cost somewhere over ₹1 lakh, the basic ones, or around ₹1 lakh. Now, just because of our negligence of not maintaining the fluid cleanliness, let us say the fluid gets contaminated, what happens? There is every possibility that the servo valve may get damaged. Okay, now we could have as well maintain the cleanliness level by incorporating the required filtration, wherein the element would have costed maybe a couple of thousands, but by not replacing that, or by not incorporating such arrangement, we end up in either replacing or getting the valve repaired, paying almost 50, 60 or 75% or 80% of the cost. It depends on the nature of failure that occurs. Okay, so that is why these pressure line filters are used wherever the application is critical, and wherever by default the electrohydraulic components are used, that is the proportional valves, or the next critical ones, that is the servo valves. Okay, so this is very important for us to understand. Then comes your suction line filter. That is what we can see here. We have a strainer, that is a simple mechanical mesh that we talk about, and this here we are talking about the suction filter. Now, filters in the suction lines are generally not recommended. Strainers are okay, but filters we need to be very, very careful. And even if it is used, we need to have a bypass arrangement. Otherwise, what happens? The clogging of the filter element in a suction line can straight away lead to cavitation of the pump. So what did we understand by the cavitation? Cavitation can lead to the damage of the pump straight away. I mean, there is nothing else that can be done. Okay, so it straight away reaches into that condition. So generally it is not recommended. Even if it is recommended, I mean, we need to take adequate precautions and ensure that the suction filters are generally not clogged or replaced much before it is clogged, or replaced immediately after getting to know that the element has got clogged, of course. But it is always, to be on safer side, we need to have the bypass arrangement and the clog indication arrangement on these particular filter elements. Okay, right. So that is another thing. And next one is your offline filtration. That is what we see here in the right side. So we have a separate pump that is catering to the filter alone, and then it is going back to the tank. So fluid is coming in from the reservoir, pump is delivering the flow to the filter assembly, and through the filter assembly it is going back to the reservoir. So this is what we call it as offline filtration. Okay, then comes bypass line. Bypass line is generally used, it is as good as tapping out part of the flow from the system and then passing it through the filtration assembly or filter assembly, and then putting it back into the reservoir. Okay, so that is what the bypass line means. Batch process and reclamation. And yes, we have a separate arrangement for this batch process and reclamation, that is for improving the cleanliness level of the fluid. So these are the different methods of filtrations that we can adopt and incorporate in our hydraulic systems, right? So finally, we come to the most critical aspect of the fluid cleanliness, that is fluid sampling and testing. Okay, now the most important part is, of course, as a system designer, he will take care and incorporate the filter assemblies at different locations. Now, as you saw in the previous slide, there might be different locations. You might be having all those things, but that doesn't mean, or that doesn't stop you from doing a sampling and testing. Okay, so generally, technically speaking, we need to do the sampling at least for about once in 6 months. Okay, and for the particle count test, and then at least once in a year for the properties of the fluid. Now, when we say sampling and testing doesn't mean only for the contaminants that are present in the physical form, that is in the solid contaminants that we try to refer. No, it is not so, because we have discussed about the contamination in 3 different forms: solid, liquid, as well as gas forms. Okay, well, liquid and gas may not be visible to you. Okay, but these two would have would cause the change or the variation in the properties of the fluid itself. Okay, contaminants, yes, of course, it is in the physical form that you can always get it done, maybe once in 6 months, but it is very, very important to get the properties of the fluid assessed at least once in a year. So that is a standard recommendation that is given in the industry. Okay, now what all do we so where do we do the sampling from? Sampling has to be taken from the line that is returning from the system. So you need to tap. We can see we need to have a clean bottle, then we had to have the epidemic cube, and then with a clean gloves and a clean cube, we need to tap the samples. Okay, so in a clean bottle, and we have to take the sample and then get it tested. So those are the contamination monitoring kits that we are seeing here. So that can be assessed. Then, as I mentioned, the next important part is the properties of the fluid that has to be assessed at least once in a year. Then we need to also get to know whether there is presence of air and gas in this particular in the particular fluid that we are using. What is the presence of water? What are the presence of chemicals in that? And what are the different type of particulates that are present in the fluid that we are using. So when we do the sampling, we need to take care of all these aspects. Okay, contamination is only one part that we do it probably once in 6 months, but people even forget that. But sometimes they do the physical particulate count test, but I have seldom seen people doing the sampling and testing for understanding the properties of the fluids, which is very, very important because that has a direct impact on the performance. Okay, as the fluid degrades, the efficiency of the system also degrades. So it's very, very important. Okay. So I think with that, whatever points we had highlighted on today's agenda has been covered. And now the forum is now open for questions. So if you have any questions, please feel free to ask. Nitesh, any questions on the chat box?
There are a few questions on the chat box basically.
Okay.
So it was very good session and very informative session. Thank you, Krishna sir. I would like to know something about this next level of contamination.
Okay.
So if anything is there, any slide is there on that, it will be useful for all this like hydraulic hose manufacturer, because like companies and customers are like asking for different level of next level.
Okay.
Is there anything on that, sir?
Well, I need to really look into that. Let me just check. In the meantime, if there are any other questions, of course, it's basically the National Aerospace Standard that you're referring to, which is not a very commonly used in current scenario. Okay, the most common one that we use is the ISO coding. Most common one that we use is the ISO coding. So ISO coding is the most important one, but nevertheless, let me just check on that in the meantime. And if any other questions?
One question is there from Powerflex.
Yeah.
Sir, are you there?
I'm very much there.
Okay. Can you ask the question, sir?
Yeah,
I think, can we do online testing of ppm?
See what, online testing of, basically what happened, lot of systems require, we cannot stop it. Honestly speaking, we cannot stop that system. And they are very sensitive systems. So online monitoring of the system is very important. This online testing, which we get from the big manufacturers, is very, very expensive. Very, very expensive. In the tune of more than 20 lakhs or something like that.
Yeah.
So I just wanted to know any sensors or something like that, which quite economical in the range to test. Means I can decide when to change the oil or when we should filter the oil, or when should I plan the system to stop and do this replacement of oil or filtration of oil.
Yes, online particulate monitoring machines are there. Those can be fitted onto the, that is, we call it as inline measuring system. So these are available and this can be used, and you can generate the cleanliness level directly on that by downloading the data, or there are different means you can generate it on that also. And yes, there are simpler ones also available in the market which can be used, but this is only for the particulate counting that I am referring to. If you are referring to the other aspects, then it has to go to a lab, a proper lab for analysis, or to understand the exact measurement of presence of the water or any other acid or chemicals that are present in the system. Lab analysis is a must for the, as far as the properties are concerned.
Nitesh, you were asking for that NAS standards, right?
Yeah.
Yeah, it is NAS 1638 is the standard. Okay, so correspondingly there is a standard which is ISO 4406. Okay. I'll just try to, I think I have a copy. I'll just try to see. Can you see the screen?
Yes, it is visible.
Yeah, this is a allocation of scale numbers where we call the NAS levels. You know, these are the number of particles. It is very much. This is a scale number, NAS level, and this is a particles allowed. If it is NAS 28, so this, these are the particles allowed. Okay.
Okay.
So this is a standard. It is basically ISO 4406.
So this covers particle size as well as particle count.
Yeah. Yes. Both.
Yes.
Okay.
It is as per NIS 1638. NAS 1638 is the basic of all these things. And ISO 4406 describes it very well.
Okay, sir. Right.
Anyone else, sir,
Okay,
from
And
the
one
box?
more question is there, Mr. Ashish. Mr. Ashish is there?
Yes, good evening, Ashish here.
Yeah, Ashish. I think your question is,
Yes,
do we have any standard specifying the
yes,
level of
it has been
cleanliness
answered.
of fluid as per application of the product? Yes, it's a very important question that you have asked. The cleanliness level of a system is always decided by the critical most component that we use in the system. Okay, so that is one thing. Second thing is, of course, it also depends on the operating pressures of the system. Now, let us say you are using the same set of components for lower pressure application and the same set of components for high pressure applications or medium pressure applications and then high pressure applications. So, but what happens is as the pressure levels go up, the stringency of the cleanliness level will also go up.
True.
So if you refer the ISO coding chart as per the SAE standard SAEJ 1165, if you refer that chart and if you try to observe the have a comparison of the various I mean, of course, that is the coding that I have mentioned is mainly for the classification of the codes, but these codes are generally recommended by the component manufacturers, by various companies. Okay, so if you take the critical most component, now let us say we have let us say a piston pump, then we have the conventional valves and the normal cylinders that are being used. Okay, but in these systems, then the piston pump would become the most critical component. So whatever cleanliness level code has been highlighted by the manufacturer, that will become as a benchmark for the application or for the system. Now, in the same scenario, instead of the normal conventional valve, let us say we are using a proportional direction control valve. So then the critical level, I mean the cleanliness level given for the direction control level valve, direction control valve will become the benchmarking for the cleanliness level. Now the same stringency increases if you try to use a servo valve instead of a proportional valve.
Yes. So it all depends on the area of application as well as the criticality of the application.
Exactly. And the same way, the scenario of using whether you should use only a return line filter or should you use a pressure line filter and a return line filter, should you also use a offline filter? So all these things will come up.
True. Thank you.
Yeah. Anybody
adding
else?
to the subject, adding to the subject what Nayan Bhai was talking about Powerflex. There are some of the systems in the market which also monitor the temperature and the contamination level, like you have mentioned.
Yes.
And they give you a report for the probable shutdown for the machine. But that's the indication. But certainly it's not a foolproof method, but still the work is going on for that oil conditioning monitoring.
Yeah, it can be. See, now there are two ways of looking at it. Now, how can they conclude a shutdown? Of course, if the fluid gets contaminated, then that means there can be more wear and tear, and all those things are fine. But one important aspect I would like to highlight here is you might be having the best of filtration system available in your entire system, the best of the ratings. Okay, but the rate of ingression, if it is greater than the rate of filtration, then your system will never come into control. You got my point? If the rate of contamination is higher than the rate of filtration,
Yes.
you will never achieve that cleanliness level. You may have to put 10 filters, but if you keep your tank open in a dusty environment without closing it, and then you have the rest of the filters, it doesn't make sense.
I know.
So things have to be in place, intact, with nothing getting exposed to the atmosphere. My experience, I will tell, in the past 3 decades, people don't even change the air breathers for years.
Yes, true.
And that is one of the key source of contaminants into the system.
Yes.
And the filters get bypassed.
True.
Yes.
I
have seen people.
Yeah.
I was talking for the servo valves basically.
Yeah.
See, we have the very critical systems where a lot of servo valves are used. And I'm not talking to the oil degradation to the closure of the system. It is just, say we are going from NAS 3 to NAS 6, just that level. If we can indication in the online system, it will be very much helpful to us. You understand? And I want some economical, some handy measures. Otherwise, what happens if we implement some very costly systems? The cost of operations goes up, and today nobody is ready to pay anything. So basically, I'm just looking at the NAS level going from 3 to 6 or 3 to 10 or something like that. So this is where I'm talking. So I'm not talking of the filtrum getting, accumulated with the dirt and all these things.
Again, another important point here.
Nayan bhai, sorry to disturb. Nayan bhai, can you speak to Mr. Sakrani of Ferrocare machines in Pune? He got some fantastic systems for all these online particle counters and online filtration systems.
Just share me his number.
Yeah, I'll share his number. He is the best person for all these activities. He is there since the last 30 years in the market for the same products. So if you can have a word, it is better, and at least he can give ultimate solution to your issues.
Thanks.
Yes, dear.
Yeah, another important point I would like to ask here, now that you were mentioning that the NAS level has gone up from 3 to 6 and 6 to 9. And now, yes, that is showing because the contaminants have increased. Now, what type of contaminants are they? Has it been analyzed? That can be done only by getting the sample analyzed at a particular lab. Okay, the number of quantity of contaminants have increased, but are they metallic particles, non-metallic particles? Are they non-ferrous particles or ferrous particles? Understanding this is also very important.
So this will be only the dust particles, because NAS 3 to 6 and 6 to 9 will be only because of the air breathing systems.
Particle is a particle. Particle is counted as a particle. It is never counted as a dust particle. That particle could be a dust particle. It can be a metal particle, non-metallic particle. It can be a ferrous particle. It can be a non-ferrous particle.
Agreed.
So how do we, let us say you have 10,000 particles. Out of these 10,000, how many are ferrous? How many are non-ferrous? How many are non-metallic? Yeah. Understanding this classification is important. Out of the non-ferrous, what are the different metals that we have noticed? And in the non-metallic, what are the type of particles that we have noticed? Is it sand? Is it swarf? Is it dust? Is it sawdust?
Yeah, it's a bit difficult because these systems are moving in the basically out. We do not know the locations of the systems, to be honest with you. And analyzing the system will be, stopping the systems, which cannot be done. So that's why I was asking for some online. Means this can give you just justification that, okay, you're gone from 3 to 9, do something, or at least change the oil or add the new oil and remove some old oil, something like that.
Yeah.
Okay. I'll just talk to Anup and take that number of that particle count.
Please.
Just check.
Sure. Anybody else?
Thank you, Krishna sir, for this wonderful session. Thank you, each and every delegate for participating and contributing your valuable time. Thank you.
Yeah.
Yeah.
Thank you, sir.
Anup.
Bye.
Thank you, Mukesh. Thank you, Prakshi, for giving me this opportunity. I wish everyone a Merry Christmas and a very Happy New Year 2022 to come in for everyone with good health, peace, and prosperity. Thank you so much.
Thank you, sir. Thank you, everyone. Thank you, Krishna, sir.
Thank you. Bye-bye.